University lesson or class today. I'm absolutely thrilled to introduce you to M&I University, which is free online learning brought to you by M&I. For those of you who might not be familiar with M&I, I'll just give you a quick snapshot. So M&I is otherwise known as Manufacturers News Inc. We are the nation's oldest and largest compiler of industrial manufacturing data. For over 100 years, we've been dedicated to connecting buyers and sellers in the industry. M&I University is our latest initiative, and we believe in the power of knowledge and its ability to transform businesses and individuals alike. Our goal is to equip you with the skills and insights and inspiration needed to stay ahead in today's fast-paced manufacturing landscape. Our carefully curated courses cover a wide array of topics, from sales and marketing to supply chain management and emerging trends. We've partnered with industry leaders and experts to bring you engaging and informative content that you can access at your own pace, wherever you are. This session will be recorded and will be available online for you. So buckle up and get ready to embark on a learning journey today with my friend Angela Thurman of Thurman Co. Angela, the floor is yours.
Well, thank you, Katie. So welcome, everyone. And thank you for joining us today for introduction to statistics for manufacturing and more. And I do want this to be an interactive session. So if at any time you have any questions, please just raise your hand, shout them out, and we can address them as we go along. So my name is Angela Thurman, and I own a company called Thurman Co. Let me just move that. We are a project management consulting firm here in Houston, and we specialize in project management solutions for small to medium-sized companies. So if you have any questions about me or the company, please reach out and I'll be happy to answer those questions. So what is statistics? Can you guys see this? Let me just move that too to make sure you can see that. Why would you want to study statistics, and what are statistics? So we're constantly bombarded every day with marketing messages that include statistics. So how many of you have heard some of these? 4 out of 5 dentists choose Crests, or X product removes 99% of everyday stains, or 94% of women saw a reduction in hair breakage. So these are just examples of how marketers use statistics in their messages every day to try and persuade you to purchase their products. But are those messages really persuasive? And if you don't understand how they arrived at those statistics, are they really persuasive? So let's try and figure out a little bit more about how those statistics could be generated. So statistics is meant to help us organize data and to make more informed decisions. And usually some of this is done through graphs. Lots of different types of graphs are used to help present that information visually. So you instantly see the data visually instead of just a lot of numbers. So in statistics, we're just going to start with some very basic information. We have 3 different terms to indicate the middle. And so why do we have 3 different words for the middle? They actually have 3 very different meanings. So the mean is the average of the given number. So all of the numbers in the data set, we calculate the average by dividing the sum of all of these numbers by the total numbers in the data set. So you normally think of that as just your the average, and we're all accustomed to calculating an average. The next one is the median. And that is simply the middle number in a sorted list of numbers. And that can be sorted ascending or descending. So out of your total data set, what is the number that is in the middle of that data set? And then the mode. The mode is the number in the data set that appears most frequently. So those are the three terms that we describe the middle. So I have a little demonstration. I have a glass jar. It's just a quart jar that I use to save all of my loose coins. And so for this for this experiment, I poured out all the coins and then I dropped them back into the jar in just a random order. And I noted the value of the coin as I dropped it in. So dimes, quarters, nickels, pennies, and I put it into an Excel spreadsheet. So you can see here, these are the entries. So I had 83 coins to put back into my jar. And then here was the value of that coin: 10 for dimes, 5 for nickels, 25 for quarters, and 1 for pennies. And I just dropped all the coins back into the jar. So I had 83 coins to put back into my little piggy bank. So now I want to show you I'm gonna stop sharing this screen. And I'm gonna share my Excel screen. Instead. All right. So hopefully everyone sees that. All right, so here are my 83 entries, my 83 coins. And then I sorted those values in ascending order. So I still have 83 entries of pennies, nickels, dimes, and quarters. And I can use Excel to calculate the mean, the median, and the mode. Now, Excel doesn't have a formula for mean, but recall that that's just the average. And Excel does have a formula for average. So I'm going to put average and I'm going to select my range of values. There we go. That's my range of values. Okay. And so it tells me that the mean of those values is 7.759. All right. Now, Excel does have a mean. And I recall that that is D3 to D85, I think. Well, I'll tell you what, I'll just select it again. Whoops, I must have. Here we go. Whoops, it didn't like that. Oh, I know, I'm putting median in. Let's do the median. Sorry about this. The median is 5, and we'll do mode. And the mode is 1. So 1 is the value that appears most frequently. So even though each of those terms means the middle, we can see that they are vastly different values for this data set. Does anyone have any questions about that? All right, if not, I'll go ahead and go back to the presentation. So there are times when you'll want to use the mean, and different times when the median or the mode may be the term that or the value that you're interested in. So the next thing I want to talk about is bias. So we want to be aware of bias when we're investigating our data and preparing our statistics. So bias is a tendency in the data or the data collection method to present an inaccurate, skewed, or biased description of reality. So this is a tendency to just present inaccurate information or an inaccurate view of the reality that the data is presenting. So statistical bias can occur at any stage or many stages. So it can occur in your collection methodology, the way that you're analyzing the data, or the way that you're interpreting the data. And it can be completely gosh, I lost the word. Unaware. You may be unaware of the bias that is being introduced, or it can be in something that you're actually introducing intentionally. Sorry about that. I'm just a loss for words. Okay, so here's an example. So a Russian news agency reported that in a race that was held yesterday in Moscow, the Russian runner came in second, but the American runner came in next to last. So what is your perception based on this report? Now, what if there were just 2 runners in the race? What if that was the reality of the situation? Can you see how the report from the Russian news agency created or presented bias in the way that it was presented? So next we're going to move on to the normal distribution, or the Gaussian distribution as it's also called. So this is the probability distribution that appears as the well-known bell curve when it's graphed. It is a symmetrical plot of the data around the mean value, where the width of the curve is defined by the standard deviation. And in a normal distribution, 99.7% of the data points will be captured within 3 standard deviations on either side of the center point. Now, one standard deviation is represented by the Greek letter sigma. And because 99.7% of the data is captured within 3 standard deviations to the left and 3 standard deviations to the right of the center point, this is how we come up with that common term 6 sigma. So here's a graph of that bell curve, the normal distribution, and the breakdown of the 6 sigma. So 68% is captured within just one standard deviation from the center point, from the mean. If we go down to 2 sigma, we go all the way up to 95%. That's incredible. And if we go out to 3 sigma, so a total of 6 sigma from left to right, 99.7% of the data is captured. Now, these tails do go out to infinity. But as you can see, the most significant portion of the data is captured within 6 sigma. And the standard deviation is also known as the standard error. The size of the standard error depends on the sample size. Now, as you increase the sample size, the total number of data points in your data set, that bell curve will become steeper and your standard error will become smaller. So we can see that increasing the sample size and reducing sample error is a positive thing. So next I want to talk about linear regression and forecasting. Linear regression, what does linear mean? That means it follows a simple mathematical formula with only one y variable. So the formula, x or y equals x plus 3 would be a linear formula. So linear regression analysis is a method to predict the value of a variable based on the value of another variable. And we want to use this to predict the future value forecasting of this variable. So the variable that you want to predict is the dependent variable. And the variable that you're using to make the prediction is called the independent variable. So a linear formula, I know this is a little bit complicated, but so we've got the slope of our line, and then here's our formula. Y is equal to our intercept point plus the slope times x, our independent variable. Y is going to be the dependent variable. And then we may have some random error thrown in there as well. So this is the observed value. And this is our independent variable, our dependent variable, our independent variable. And then all of these data points, you can see, are scattered around, but they are generally trending in this direction. And then we calculate this line, this trend line, and that allows us to calculate future values of x that we haven't yet observed based on this formula. So let's say that we've got sales values for the last 3 months, and then if we calculate this formula, we could forecast sales values for next month and the following month and so forth. And that's how we arrive with forecast values. So with this value of the regression line now defined, you can determine how well that data fits with the formula. And that's known as the correlation. If I go back to our previous slide, we can see how well does this line represent those data points. And that's known as the correlation, which is represented by R. And then this, again, that formula can be used to predict or forecast future performance or trends. So that process, again, is to you gather your data, you use linear regression to find the formula of the trend line, and then you forecast future performance or trends. And all of this is done using statistics. So let's talk about process capability. Now, this goes directly to manufacturing. Process capability compares the outputs of an in-control process. And we'll talk about in control and what that means in a later slide. So it compares the outputs of the process to the specification limits by using capability indices. The comparison is made by forming the ratio of the spread between the process specifications to the spread of the process values, as measured by 6 process standard deviation units. Again, we're back to that 6 standard deviation reference point. And then a process where almost all of the measurements fall inside the specification limits is capable. So when we talk about specification limits, what might that be? Well, a specification might be that the diameter of a pipe is 3 inches. And then the limits would be plus or minus a quarter of an inch. And then another example might be that the volume of this container of milk is 1 gallon, 64 ounces, plus or minus a quarter of an ounce. Or the weight of this bag of rice is 2 pounds, plus or minus a quarter of a pound. All of those are specifications, and then the limit is the plus or minus, an upper limit and a lower limit. And that is how you would define your specification limits. And this could be for anything that could be measured. That could include weights, dimensions, torque, voltage, anything at all in your manufacturing process that you might measure throughout the manufacturing process. And you're going to find this especially in the testing and quality parts of the manufacturing process. So when we talk about capability, we're going to, again, this is how we would define the upper and lower limit. So the mean, the central point, is going to be our specification. And then we'll have 3 sigma to the right, 3 sigma to the left. This is going to be our lower control limit and our upper control limit. So let's say that the voltage at a test point is supposed to be 9 volts plus or minus half a volt. And anything beyond that is going to be defective and it has to be rejected. Any questions? Okay, if not, I'll move on. So let me just say, if the measurement is taken and the measurement falls within the upper or lower control limits, then the process is capable. And the unit being measured is accepted. If it falls outside of those limits, it is defective and the unit has to be rejected. So process capability leads us to a process capability measurements. So we say that the process capability for a two-sided specification, that means it has an upper and a lower limit. We measure process capability using the upper limit minus the lower limit divided by 6 sigma. Process capability based on only the upper limit, it's the upper limit minus the average divided by 3 sigma, because again, it's only one-sided. If the process capability is based on a lower limit, then it's the specification limit minus the lower specification limit divided by 3 sigma. And then the minimum of CPU and CPL is what we call CPK. This is the process capability for a two-sided specification limit, taking account where the process is centered. And CPK is a very, very common measurement for manufacturing process reviews. And you'll see this frequently in quality review boards. This is frequently an indices or an index that customers will want reported, and this is all, it all goes back to your upper and lower limits and your sigma or your error, your standard error. So now we're getting to statistical process control. And this is how we determine whether or not that process is in control. So SPC monitors the manufacturing processes, and we use technology to do that. So this is a measure of quality. SPC triggers various machines to provide quality data. So that machine has to have some sort of technology to measure the data provided by the data about the product and the measurements and the processes being read. So for example, it has to have a place in the manufacturing process to take those measurements, to take the dimensions of that black box, or to take those voltage measurements, and to then feed that data to some central information collection point. And then the data is evaluated, monitored into the control process. So a process is said to be in control if it does not violate any of the 7 rules for process control. So let's go over what those 7 rules are. So here's just an example of a process control chart. And there are 3 zones of interest, and they all center around the here's the average or the center point of your bell curve. So if the data being collected falls within 1 sigma from the average or the central point, then it is said to be in zone C. Whoop, that should have been a C instead of a 3. If it falls within 2 sigma, then it is in zone B. If it falls within 3 sigma from the center point, then that data point is within zone A. And so these are all the measurements being collected. And you can see, for example, this data point is outside of zone 3. So that's probably a defect. So let's talk about the 7 rules. If one or more points, one or more data points is beyond the control limits, then that would be a violation. If 2 out of 3 consecutive points are in zone A or beyond, that would be a violation. If 4 out of 5 consecutive points are in zone B, that would be a violation. 7 or more consecutive points on one side of the average in zone C or beyond would be a violation under the zone C rule. 7 consecutive points trending up or trending down would be a violation of the trend rule. 8 consecutive points with no points in zone C would be a violation of the mixture rule. 15 consecutive points in zone C is a violation of the stratification rule. And 14 consecutive points alternating up and down, so up, down, up, down, up, down, that would be a violation of the over control rule. So if I go back to our control point here, we could see that this is a violation of the out of bounds rule. And then here we've got 1, 2, 3, 4, 5. We've got 5 rules that are all in zone C. 5 points rather, 5 points all in, but that it takes 7 to be a violation of zone C, so that is not a violation. But this is the type of review you have to take to look at your control chart to see whether or not the process is in control. But we can see from this single point right here that this is beyond the control limits. So that process is not in control. And so further investigation would be required and measures taken to get the process in control. So for quality improvement, how is statistics used for quality improvement? So statistical methods are defined as the use of collecting data and the quality standards to find new ways to improve products and services. So we use statistics ultimately to provide better products and services for our customers. And statistics itself is a formalized body of techniques involving attempts to infer the properties of a large collection of data and then presenting that data in an organized fashion through the use of charts and graphs. No one wants to look at reams and reams of numbers. So that's why we use charts and graphs to better present that data in a visual representation that quickly provides the summation of what all of those numbers mean. So some common statistical methods that are used in quality improvement efforts are hypothesis testing, which we'll leave that topic for another day, regression analysis, which we've already discussed, statistical process control, and then design and analysis of experiments, which again, we'll leave that topic for another day. And then here are some practical considerations for the tools, the considerations, and then how statistics can be used for those quality improvements. So process capability indices. We do want to make sure that the sample sizes are large enough to be representative. The regression coefficient, so that's the R value that we talked about in the linear regression. An R value greater than 95% gives us confidence that the equation is representative based on the data. Process optimization, we want to optimize the conditions with the responses. So we want to be sure that we're actually using the responses and the objectives. So there are going to be some trade-offs. And so eventually you reach the point of no return if you keep adding more and more objectives. And then screening experiments. So the number of runs has to be large enough to detect a significant effect. And again, you're looking for that 95% confidence or higher. And then gauge repeatability and reproducibility studies. So this would be an experiment where an individual is making an experiment with a gauge. Let's say it's a tool that they're using. It could be a micrometer. And so you have to do at least 5 to 10 samples in the study for it to be significant. So that individual has to be able to repeat and reproduce the results for that study to be representative. Okay. So ultimately, the reason we use all of these methods is so that our quality control professionals can pinpoint the root causes of the problems that are leading to these defects. We want to implement corrective actions to resolve the causes of these defects. And then this is so they can lead the organization to produce products and services that are improved, and then providing the customers with better, safer, and more desirable products and services. So although it's frequently the quality team that is employing all of these statistical methods, it could be anyone in the organization that uses these methods. So whether you're in sales or marketing, engineering, project management, we all can use some of these statistical methods in our daily work, whether you're doing demand planning, project management, engineering, design. There are elements of statistics that we can employ in our daily work to help improve the delivery of our work, to improve the products and services we provide to both our external and our internal customers. So that brings me to the close of our course today. Here's my contact information. If you have any questions, please feel free to reach out, and I'd be happy to answer any questions you have about the course or about the services of Thurman Co. as well. So with that, I think, Katie, I'm ready to turn it back over to you.
For covering that. I found a connection with a few of the things that you showed on the screen. Like, for example, when you showed that bell curve, it really was reminiscent to when my kids were little, and then we would get the chart from the doctor that showed that where they were on the growth chart, and that's what the chart was a bell curve. So that's when I saw that. So now I understand, 22 years later, now I understand how that data was gathered. That was pretty cool. Stephanie wanted us to know that she thought it was a great overview. That was nice. Thanks for being here, Stephanie. Statistics has always been kind of close to my heart. When I was younger, my dad worked at the Wapaka Foundry, and he was in charge of quality control there, and statistics was his thing. And he taught statistics to all of the different plants. So he always told me that it was over my head and I couldn't get it. Was little though. And I remember when I was in high school, they introduced a statistics class and I wanted to take it. And he told me, I don't think you should take it. So I'm going to be excited to go back to him today and tell him everything I learned. Um, but does anybody else have any questions or anything? Do you want to offer any insight? If you'd like to, you can take yourself off of mute and you can add to it. Yeah, Jennifer said it's super interesting. I don't think I have anything else for you guys. Angela appears to be done. Thanks again so much for your time today, everybody. Feel free to reach out to either of us afterwards. I will be sending out an email shortly and follow up with some key points and a link to this recording that you can always access whenever you need to, wherever you are. Thanks, Angela.
Yeah, thank you. Thanks, everyone.
Great day.